All right, so today we're going to be talking about linear programming again. So I want to start with just a little bit of a review of the different terms that we talked about. So when we were talking about linear programming the first time around, we talked about a thing called the objective function. So just a reminder, the objective function is the equation that you're trying to minimize or maximize. And you'll usually be told in the problem which way they want it to go. So do you want to minimize, do you want to maximize the situation? Otherwise, you're always looking for words like profit or costs or, like things that you would want either to have a lot of or a little of. So if you're looking at something and it doesn't necessarily say to minimize or maximize, look at what you're working with. So if we're talking about profit, we probably want the maximum profit, not the minimum profit. Or if we're talking about costs, we probably don't want the maximum costs, we probably want the minimum costs. So just use a little bit of logic there if you don't see a specific, like, maximize this thing. Constraints were the inequalities that we have based on the scenario. So whatever the scenario is about, the inequalities are the things that you're going to graph to create kind of this polygon region of possible answers. Now the corners of those inequalities, so once we graph, we have like a picture that looks something like this, and we have this shaded region. The corners of that shaded region are called the vertices. So that's just a quick little review of the different parts of linear programming that we've talked about. So sometimes you're going to have a word problem, sometimes you won't. So like, for example, in this scenario, it's not a word problem. So little trick for us, whenever we see, first of all, notice it's an equation, not an inequality. When it has a letter, usually P, this is our objective function. So this is the thing that we're going to minimize or maximize. In this case, I'm going to have you maximize it. Okay, so whenever we see inequalities that look like this, where there's like two numbers on either side, when you're graphing that, all you're going to do is graph both lines. So I'm going to graph x is greater than or equal to 0, and I'm going to graph x is less than or equal to 18. So since it's an x value, those are the vertical lines. So one of them go right here at 0, and we're saying x is bigger than 0, so I'm just going to make a note of that to myself right away by drawing in some arrows. Now x is less than 18, that would be over here at 18, and we're saying x is smaller than that value. Now this next one here has that same setup where there's two numbers, one on either side, and we're just saying y is between these two numbers. So I would make a line at 4. We're saying that y is greater than 4. And then y is less than 31. So right there. So right now we've got kind of a rectangular region, it appears, that we're working in. But this last function is going to tell us which way to go. Now, we generally want to have these equations set up in like a slope-intercept format. So I would want to solve this equation for y. So I'm going to do that by subtracting the 8x to the other side. So I end up with negative 8x plus 80 is less than or equal to 2y. And then I would divide by 2 to get y by itself. So my function ends up being negative 4x plus 40 is less than or equal to y. Remember, the only time that sign would flip is if I was dividing by a negative, which I'm not here. So now this equation is set up in a way that I could graph it. So y-intercept is at 40, slope is negative 4, so that means I go down 4 and to the right 1. So just trying to make sure I'm following my scale correctly on my graph here. that would look like this. Okay. You don't necessarily need to draw in all those points. I just did it so that I would be able to see where things fall on my graph. Okay, now this line, I always have a hard time telling which way I'm going to be shading just by looking at the equation, so I'm going to plug in a point. Now, we've talked about this a ton of times. Whatever point you want to plug in, you can, as long as it's not on the line. So I'm going to pick 0, 0 because it's not on our line. Now, when I plug in 0, 0, you can plug it into the original equation or the one you made. I generally go back to the original. So when I plug in 0 here and 0 there, both pieces cancel out, and I get 80 is less than or equal to 0, which is not a true statement, meaning this side of the line is not true. So I would be shading on this side of the line. Now, whenever we do our shading here, we're always looking for wherever the arrows are all pointing towards each other, which in this case is actually this space over here. Okay, so we've figured out all of our shading, which means that now we're ready to find our vertices, our corners. So it's a little bit hard to tell on my graph because I didn't do a very nice job of graphing my coordinates. This would be at 2, 30. This one over here, or I'm sorry, 31, looks like. Then I've got 18, 31. 18, 4. That one's hard to tell. Ooh, now that I'm looking back at this coordinate, this would actually be at 2.25, comma 31. This one, I'm having a hard time seeing that coordinate, so I could actually go through and solve and figure that out. So basically what we would need to do to solve is we know the y coordinate is 4, since we're on this red line, which is at 4. So I could just plug in 4 for y and figure out what x is. So I'm going to do that quick. So if I plug that in here, I get 80 is less than or equal to 8 plus 8x. So subtract the 8, I get 72. It's less than or equal to 8x, which means that x is going to be 9. So that means this coordinate here would be at 9, 4. So if you're ever having trouble telling from your graph, you can always just, if you know one of the coordinates, plug in the other and solve. Just use your algebra skills. So we've got our 4 coordinates. Then we would plug them into our objective function in order to see which vertex is our answer. So I'm going to erase some stuff, make some space for us to work with. Okay, there we go. So when I plug in my coordinate 2.25, comma 31 into here, I get 6 times 31 minus 3 times 2.25. I would pull out my calculator to do that math, as you should do also, unless you want to do it in your head, which is fine. So 6 times 31 minus 3 times 2.25, and I would get 179.25. Then I would plug in my next coordinate. So I'm going to go over to here, which we said was at 1831. So 6 times 31 minus 3 times 18. We would get 132. Plug in this coordinate, so 6 times 4 minus 3 times 18, which would be negative 30. Plug in this coordinate, so 6 times 4 minus 3 times 9, which is negative 3. Since I said I wanted to maximize my function, that would mean that this coordinate gave us the largest value of 179.25. So the correct answer here would be 179.25 at the coordinate of 2.25, 31. So our solution is actually the coordinate. Okay. So we're going to be looking at a new situation. Now, like I said, a lot of the times this is more of a real world type item, so you're actually creating equations that would go along with this. So what I would like you to do is pause the video, try out this problem, and then come back and check your answer. Okay, so you should be coming back after trying out that this problem. So I defined X as gym bags and Y as hats. On my graph, I used a scale of 10. So when you're looking at this, this is scaled by 10. It's on both axes. So found my objective function to be 8x plus 6y. That came from they're going to make a profit of $8 on a gym bag and $6 on a hat. Found my two constraints based on the $800 they had to spend and not selling more than 120 items. And then I found my corners, my vertices. Tested them out, and what I came up with as an answer is that they should sell 80 bags and 40 hats. Now, we're going to head on to the attendance check. So what you need to do to make sure that you get marked present for today, in case you forgot, is you have to complete whatever attendance check there is. So right now it's on Schoology. It's in the folder labeled 10.9, and the password for it is focus with no capital. So it's just a lowercase f. So again, in case you're having trouble finding those items, it should be right here, folder 10.9, the attendance check. And when you are going in to complete that, it has a password of focus. Okay, so then let's head back. So, another problem for you to try out. Again, it's set up in a very similar format to the last one, but I want you to pause and see if you can do this one on your own. One of the best ways that you can learn from this kind of stuff is to pause, try it out, and then come back. Okay, so we should be coming back after testing this problem out on your own. So I chose to use X as messenger bags and Y as backpacks. My objective function ends up being 12x plus 24y is equal to our profit. Just realized I don't have the P in there. And I got these as my constraints. So 2x plus 3y has to be less than 30 because that represents the number of hours it took to make the bags. And they said they only have 30 hours available. And then the total number of items needs to be at least 12. So x, the number of messenger bags plus the number of backpacks has to be greater than or equal to 12. So first things first, I go through and I graph, and then I have to figure out where I'm shading. So I plugged in the point 0, into both equations. So when I plug it into this first equation, I'm shading below this line. But then when I plug it into the other equation, this is where a lot of students make a mistake because they assume that you're going to be shading in this bottom corner region, but you're not, because if you plug in 0, it actually comes out as false for that other line. So I need to shade above this line, which would mean that this little space here is where I'm actually shading. So my three corners are really 15, 0, 12, 0, and 6, 6. So when I plug them in and test them out, I get 6, 6 as my answer. So 6 messenger bags and 6 backpacks. All right, so you do have some practice to end the day here. So if you go to 10-9, the folder that's labeled for today, first of all, make sure you have your warm-up and your attendance check done. So the attendance check, the password on it is focus. So when you go in there, make sure you have that typed out correctly. And then you have some practice here. Now the practice is set up in a PDF document. I do not expect you to print it off, but you can use something called Cami. It's a Chrome extension that you can get. So if you don't already have it, it's in the Chrome store, whatever they call that. And you can open the document that way. So when you open using Cami, one of the cool things about it is that you can write right on the document. So cool thing also is that your computers are touchscreen, so you're able to actually do this on your own screen. So you're going to want to go through and graph. So, come up with one of your lines, your other lines, your last couple lines, and figure out your shading. Do your best to be as accurate as possible so you are able to zoom in to make sure that your lines look good. And obviously you're able to change colors if you want to have multiple colors going on so you know what's going on in your graph, okay? Identify your vertices, meaning find your corners. Tell me the maximum and the minimum. So there are 4 total problems on here for you. When you're done, just make sure you save it. So save the whole thing. I believe, right here, there's a button for that. And then you can turn it in, I believe, right there. Otherwise, save it, and then go back into Schoology, and you can upload the assignment in here, okay? So that is the final piece. Now, this is something that is going in the gradebook, so please make sure you have it done. It says right on here, make sure you submit this assignment by Tuesday, so next week, Tuesday. That gives you 4 days to work on it at 3:40, okay? So this is actually going in the gradebook. It's our linear programming problems. I'm looking at it more in the terms of the inequality part of it for now. I'm not quite ready to test you on linear programming as a whole.